It's good to see you, Neri, and we'll have about 1 hour to speak about hopefully many different issues. I'm sure most of the guests know you, but just to give a short introduction, for the record, you were born and raised in Israel. You first studied medicine in Israel and then changed to architecture in Jerusalem. Then it's the Architectural Association, where you graduated. Then you changed to MIT, joining the PhD program. You became a professor at MIT in 2010. You founded the Mediated Matter Group. You received a lot of awards in the last years. You gave a wonderful TED speech in 2015. And I think you're really one of the people in design, architecture, and research which have changed the rules in the last years of how things are created, about how we think about creation per se. And I hope we'll have the occasion to speak about that, about these different attitudes of how things can come into life and can be created. Yeah, I think also your biography gives us a lot of connecting points to speak about interesting questions. At the moment, you have an exhibition at MoMA, which yourself mentioned as a very important point in your career. And I would also like to speak about what you meant by that. I read you see it as a transition of previous research into new contexts, new, as you called it, real world application. So I'm really curious to hear more about that. But maybe let's start with some basics. You know, what is on view at the exhibition? Are you showing projects from the last 15 years, from all of those phases of your previous research?
So first of all, thank you, Matteo, and thank you, everyone. I see all the hearts, and I'm loving it. I'm really, really thankful to have this opportunity to talk to you and to share, you know, some of my thoughts, my team's thoughts about the previous work we've done, sort of where we've been, who we are, and where we're going. And I think starting with MoMA, actually MoMA is sort of the starting point, and in a way, MoMA is sort of my relationship with Paula started so many years ago, in 2007, when we worked on the design in the Elastic Mind. And the work shown in material ecology really includes the breadth of work that we created over the past, I would say, 15 to 20 years. Mm-hmm. So it's sort of an end point, but also a starting point for a new beginning, a new thinking about the future. Paula is not she's a very, very special curator. She's, as so many of you know, and so many of you have known Paula, and she's a creator curator. I think she thinks about curation as an act of creation, and curation for her is very much an act of design. And what Paula did with this show, Material Ecology, where she presents our work, you know, that spans such a wide range of projects and technologies and a timeline, she decided to not include applications, not include any objects in the exhibition. So, you know, we didn't have, you know, no chairs, no wearables, and no sort of fully fledged architectural structures. These were, as Paula calls them, demos. These were expressions of processes, expressions of technology. And what was interesting is Paula, her decision was so bold in that, you know, I think it is a lot asking from a visitor to an exhibition in design to enter without and leave the expectation to see a design product at the door. And really what it is a collection of technologies. And I say with confidence that there's not a single product that we've created in my group for which we did not create the technology. And that is a very, very important point when you enter our work and try to understand it. The relationship between product and process is incredibly and very tightly linked. And yes, Paula embraced that vision. And so the show, which I hope many of you can visit still till October 18th, is this compendium of tools and technologies exploring different material systems and what we can do with them for looking into the future.
It looks like a laboratory, no? It's a place with samples, with technologies that you develop for the projects that are shown. But I think it's a very smart choice of Paula and of you too, to really see it as this collection of raw material, right? And ideas that can be used in different directions. Maybe showing objects would also limit the view of the visitor, or the understanding of the potential that is in those technologies to a single application. But probably you want to think about them as a very open field of possibilities, and probably the Kaidin objects offer not only the possibility of creating one type of objects, it's a technology, it's a material that you could use for various other applications, right?
Yeah, it is very much a lab, and Paula and her team attempted to bring, and I should credit Anna, who worked closely with Paula on this show. So both Paula and Anna attempted to bring as close as possible the vision of the show to what it is to be in our lab at the Media Lab. And that included, you know, the various libraries. We always create a kind of a cabinet of curiosities for each of the projects that we create. And I think for most of the projects shown at MoMA, we do have a kind of a library of experiments or a cabinet of curiosities that takes the viewer through the process that we've been through before and while we were creating the technology. So for example, with the Silk Pavilion, you can see all of the small scale experiments that we did with silkworms in collaboration prior to engaging the large scale project.
Mm-hmm. That's super interesting. And that was one thing I was going to ask you about, because the Silk Pavilion is probably your most famous project so far, although there are a few others that are super widely published and we'll be able to speak about. But the Silk Pavilion, you were mentioning already in the TED talk that this pavilion combines for you these two worlds that you want to merge, right? It's the, let's call it the Cartesian rationalist world, the engineering world, which is represented in a structure that is created by a robot, a woven structure. And on that structure, you place those silkworms, which are doing their own work. So you let nature grow on the engineered structure. Can you tell us a little bit more about how did you develop that idea? I mean, first of all, you have to have the idea of using silkworms to fabricate something for you. And then I'm sure it involved a lot of research in biology and behavior of those worms. How was the process?
So taking you back to 2012, actually 2010, when I gave my job talk at MIT, I was applying to a faculty position. I was asked the question, what will be your first project? And I did have a silk cocoon in my pocket. And I took the silk cocoon out of the pocket and I said, we're going to study the silkworms and build a silk dome. And the reason my love for silkworms came, you know, at the time we were looking at additive manufacturing and 3D printing technologies. And I thought, wow, the silkworm is sort of the best embodiment of an organism that so elegantly transcends all the limitations of 3D printing. It transcends the material bottleneck. It spins with one of the most superior materials there are on the planet. It transcends the gantry size limitation because it creates a house in which to live in that's bigger than the size of the gantry of its body. And it transcends the process limitation in that it doesn't quote unquote spin in layers, but it spins in 3 dimensions. And so I was personally fascinated with how such organisms like the silkworms, later the bees and other organisms that we've looked into go about creating these incredible material architectures that are not made of assemblies of objects. This is usually how we humans design, but rather are made of continuous materials. And those materials vary their properties constantly, continuously: mechanical properties, optical properties, chemical properties, physiological, etc., etc., etc. And so the fascination was one that that I see all the notes, they're wonderful, that had to do with process and processing of material. And so we started to look at the silkworms. We actually, if you look at the first silk pavilion, we actually had a video where we 3D scanned the cocoon, and we said, great, this 1 million or so point cloud we can feed into the robotic arm and then scale up the cocoon. And that of course ended up with a complete disaster, but it got us to create a new kind of technology, a new kind of patent that we called freeform printing. When we went back to the drawing board, we were sort of sitting together by the lab thinking, how can we in 3 months, this was our deadline, produce a pavilion with the help of these wonderful creatures. And we've noticed that in the absence of a vertical axis, meaning a table corner or a tree branch, the silkworm will go about spinning its cocoon, but in flat patches. Not a 3-dimensional cocoon. It's still the same 1 mile worth of silk, but it's a flat patch. And the metamorphosis was entirely natural. And that's when the eureka moment hit us. Wow, how is it that we're boiling these cocoons in silk farms across the world, and yet we're not utilizing is the wrong word, but we're not co-fabricating and cohabitating with them together while enabling them to undergo a healthy metamorphosis. And Silk 2, the one you see in MoMA, the one that was commissioned by Paula and Anna and their team, was sort of taking that idea forward. We had not a, what was it? Not 5,000 or so silkworms. This was equal to the Silk Road in terms of trajectory, but we had 15,732 silkworms for the second pavilion. I happen to remember the number, which is rarely the case. But this is twice the length of the China Wall, right? This is a huge length of silk that, when combined together, is worthy of many shirts. For each shirt we create out of silk, we kill 1,000 silkworms on average. So the project really started to ask questions that are not only associated with structural optimization and how to utilize a collaboration between a robot, a human, and an organism, but it started to become a vehicle for ethical questions along the lines of, why are most designs human-centric? How can we think about treating all species as equal? Is that even a relevant question for architects? And if so, why? And so we started taking this to the next level. Going back to the structure, yes, we built a jig, and you can see it in the video in our website. It was horizontally situated. We went all the way to Italy. And sorry for, I hope you're enjoying the description, because we most definitely found it challenging. In America at that time, we did not have silkworms to work with. The United States was, all the silkworms in the United States had what was called the nuclear polyhydrosis virus, NPV. I hope I'm pronouncing the name correctly. But this virus basically it creates a pathological condition in the silkworms. So we took the team to Italy, and in Padova, in the beautiful mountains near Padova, in Abano Terme, beautiful area near Padova, we found this incredible woman with an incredible silk lab, Silvia Capellozzi, and we formed a beautiful collaboration where we were in her center of epiculture and sericulture, where we were working with healthy silkworms that were, if you remember the original Silk Pavilion, we FedEx ordered the silkworms online. Here we were working with silkworms that were fed with organic mulberry leaves. I mean, the way the trees were grown was without pesticides, etc. So that project really took Silk One to a completely different level in terms of, I would say, not only aesthetics but also ethics.
Mm-hmm. It's super interesting to hear that prehistory or that history behind the object, you know. I think that's what you call working with nature, no, or editing it rather than working against it. And I think it becomes very obvious when we understand all the questions that are raised during the process, which goes down until how do we treat the silkworms, where do we get them
Absolutely.
from? And I think that is a holistic approach that that is super important to understand. So it's not only about the pavilion and a new structural object, but creating a whole new process, right?
Exactly. What was most interesting was the jig was actually about 10 meters long, about 5 meters in diameter, and the jig kept rotating. So every 15 minutes we had a full rotation of this entirely very large structure. And as it rotated, the silkworms were climbing up vertically on the structure. The jig, of course, rotated, using electronics and technology, but there was what was so fascinating about the project for us was that kind of moment of collaboration between us, the designers, between the jig, the robot, and the silkworms themselves. There were 3 different structures. There was the jig itself, which was designed by us, of course, and there was an intermediate layer we designed as well, which was a water-soluble mesh. And on that water-soluble mesh, the silkworms were positioned, and over the duration of several weeks, we've built this, we've spun this large pavilion with the silkworms. And interestingly, the rotations basically facilitated the movement of the silkworms on the structure such that we can get an even, more or less even distribution of silk on the structure. There were also holes that were carved into the structure to guide better the environmental conditions, to release some of the structural tension in the structure. But what was interesting is that over time we started seeing these little holes in the soluble mesh. And those little holes were the result of the natural metabolism of the silkworms themselves. So just excretions of the silkworms that were creating these little holes. So we really saw this kind of quote unquote metabolic resume. And interestingly, the holes that were created as a result of the metabolic resume released tension in the structure and assisted in the overall structural optimization. And that was a really interesting moment, even philosophically, for us to sort of come to terms with how that kind of collaboration, it was truly a collaboration between us and these wonderful creatures, could assist in sort of structural optimization in larger scale, just enabling those silkworms to metamorphosize naturally.
Let's move on to another project, which is also in the exhibition, which is the Ocean Pavilion and the Agua Hoja project. If I understand it right, the Agua Hoja is somehow a continuation of the Ocean Pavilion idea, right? So
yes, that's correct.
You start with the material of chitin, which is one single material, and later you get to biocomposites where you combine different materials. So what I found interesting here is that you spoke about different qualities that you can reach and combine within one single material with the means of 3D printing. So you can really control the graduation of density, probably also of color, of static qualities. So what does that mean on a technological level? I mean, how can you control that when it's 3D printed? Can you tell us something about that?
Absolutely. So just taking one step back, what you saw in silk, you see in glass, and in silk fibers and glass, biomaterials or biopolymers with the Agua Hoja and the Ocean Pavilion, and then hybrid living materials with Vespers. So I think in all of our projects, all the works that you will visit in the exhibition have that in common, that notion that we're using a single material system and we're varying the properties of that material system globally and locally to produce both the overall form of the structure and the behavior, the performance of the structure, whether it be structural performance, environmental performance, or combinations thereof. Now, in Agua Roja, it's true we had, we had the first pavilion, and then we had two other. The first pavilion was sort of a demonstration of a few of these hojas, of these surface. Second one we designed for the Cooper Hewitt, they were exploring different things, but essentially both of them were made and designed using the most abundant biopolymers on the planet. So chitosan is one of them, cellulose, pectin, and some calcium carbonate. And the variation of these materials, again, this is not about material selection at all. This is not about the kind of traditional, oh, let's look at the Ashby chart and let's choose this composite with this kind of wood and this kind of metal. No, let's create these materials from scratch, and let's create and inform their molecular behavior to instigate structural behavior on an architectural scale. That's, that's a big deal. That's why you get PhDs. So just as an example, one of the things we've discovered that informed the structures, as your question suggests, was a robotically informed material anisotropy. So we found material anisotropy basically allows us to control the distribution of forces in the material, thereby impart structural and environmental behavior. We discovered that the robotic arm we designed that allowed us to mix between material composition actually contributed to the alignment of crystalline structures over the surface area that informed the structural behavior. So that was fascinating for us, the ability that you're creating molecular scale maneuvers, mediations that inform the overall scale of the structure. So chemistry informing architecture, as opposed to the other way around in the creation of a new technology. The robotic arm itself, the way it worked is that there was a mixing chamber that allowed you to mix between the various compositions. And once the structure was printed, these were mostly the skin elements of the structures. They were left to find their shape in contact with air. So sort of hydration guided self-assembly, if you may. And obviously the type of pattern that was inscribed in the structure obviously informed how that structure would later fold or unfold. And so self-assembly, self-organization, a very heavy and deep dive into understanding material properties, and all of these come together to create the robot that enables us to create this pavilion. What's also interesting is that in a way the designer is moved outside, and the robotic arm, quote unquote, does it all, because we found out that, for example, the type of pressure that we assign to the robotic arm can inform the thickness of the structural member. And so you can connect a finite element analysis structural calculation to the robotic arm, to the jet that's sort of the pump that's assigning the pressure, and create the structure, quote unquote, for free, taking out the designer out of the equation. Of course, this is not the case. But Jorge and my team developed an entire PhD called Fabrication Information Modeling, FIM, that was dedicated specifically to this theory and practice. Yeah.
So when we go back to the initial question, you mentioned that this MoMA exhibition means an important phase in your career. I heard out of that quotation of yours that there is a desire to take this a step further and to now see what applications can there be for these technologies. Of course, you have already demonstrated applications for building structures, for creating certain types of objects. But if you look into the future of those technologies and those applications, where do you see fields that you would like to test where this could be applied?
Yeah, so I think it's a challenging question, of course, because there's sort of a matrix of, on the X dimension you have size and scale, and on the Y dimension you have complexity, and some of these technologies can be implemented in the real world sooner rather than later, whereas others will take more time to develop. So for example, also the smaller you go in application, the faster you can implement, generally speaking. This is not the case for all the technologies, but generally speaking. So for example, the technology we developed for the death masks, for Vespers, that is shown at again, we started with death masks and we ended with a real world technology that explores what it means to incorporate life within objects. The technology that we've created there, called hybrid living materials, HLMs, can find a home in biomedicine, in pharmaceuticals, in cosmeceuticals, and the medical industry, specifically tissue engineering, because there what we've shown is that we can utilize printing to incorporate enzymes as the printed matter within the object and activate the object using chemical signals and incorporating synthetically engineered microorganisms in the object. So the object really comes to life. And what's interesting is that the quote-unquote coming to life can be templated at the resolution of the printer, so 16 to 20 microns. So there, the applications, the real-world applications are, I would say, medical industry, especially associated with product scale. The glass printer I could see applied at the architectural scale and having serious implications potentially for the built environment, architectural design, and urban design, especially if we can push ahead our ability to design vessels, pockets, and channels that can harness solar energy and can sort of revisit the way we think about facade engineering from the bottom up. That would be very, very exciting.
Yeah, that would be my next question. You know, you don't seem a person that is driven just by technology and just trying it out as a purpose per se, but seeing it in a global context. So what are the ideas that are driving you, or the potential that you see? I suppose it will be linked to sustainability. Is it about using less material? Is it about having manufacturing processes which consume less energy? I think these could be goals that you reach with those approaches, and that at the end have a real impact in how we use objects, but also probably the life cycle they have, if you think about materials that degrade biologically.
It's interesting. So I would say all of those things, but when an engineer, when an engineer approaches these questions associated with sustainable design and sustainability in general, the engineer, I always say the difference between the engineer and the designer is a little bit like the salad and the soup. The engineer designs a system that is a whole that is made of the sum of its parts. The engineer knows how to put the system together and how to take it apart. The engineer also approaches the challenge from a problem-solving perspective. The designer, however, approaches the problem from a problem-seeking perspective. So how can we explore? How can we less problem-solve, more problem-seek, using or creating solutions we never know existed, or offering solutions to problems we never knew existed, which is very much in the spirit of the Media Lab. I think that, so going back to the soup, the designer creates a whole that is bigger than the sum of its parts. And again, we started with a death mask, right? We started with a project that was incredibly abstract. And this was part of the intention, was to release the pressure from needing to answer a question or solve a problem. It was just for the sake of exploring how to create a living product. And we started with the death mask because we thought, this would be sort of the untouched territory. No one would ask us for the function of the death mask, so it would be considered more as an abstract project. Then we ended up with a real world technology, hybrid living materials, that enabled us to incorporate living organisms inside a product. And then came the application, tissue engineering, creating products that are able to respond, adapt, etc. And so I think in our case, the technology sort of offers the how should I say, reveals the design opportunities as we move forward with our projects. It's not that we identify a problem or a challenge and work backwards, but we start with a process and we discover what are the different products and challenges that we can, approach, resolve, revisit.
Well, you worked a lot with 3D printing. You created a 3D printer that for the first time was able to print optically transparent glass. And also 3D printing with chitin, etc., were really completely different approaches to this technology. To my understanding, there was a certain phase where a lot of designers, also product designers, were experimenting with 3D printing around 2010, 12, 15. As far as I see, the hype around the technology has gone down a little bit. What I find interesting is that yet there's still a lot of progress being made, but maybe it's progress which is more behind the scenes, which is less spectacular. It's not about printing the first 3D printed chair anymore, but finding different materials, developing different, or speeding up the process as well. How do you see the future of that technology on a long-term basis?
Yeah, it's interesting because many identify us as the 3D printing group, which we don't at all. 3D printing happens to be there as a technology that offers a way to approach single material systems as opposed to assemblies. And once you understand that, you understand the group. It's not about 3D printing. It's about finding ways to create, design, and deploy single material systems that display or that embody variation in properties as a function of structural, environmental, even social constraints without needing to assemble. And that is very much in line with nature's way. Of course, the ultimate path is, of course, to explore growth. And so when you approach the work through that lens, you can use a laser cutter or a water jet cutter, or you can use a laser cutter on a elastic plastic-based material to explore sewing. Don't try that at home, but you could sort of think about a printer as a milling machine, and a milling machine as an additive manufacturing tool. It's just a question of how you position yourself relative to that technology. I think, look, there is a future for 3D printing. I think especially if these companies developing printers approach the biggest problem, which is the biggest bottleneck, which is materials. And then take it to the next level. Now, do I think we should 3D print buildings entirely? No, absolutely not. And we see lots of examples of such technologies that basically are designed to build and deploy in the same manner in which we did 100 years ago. But that's not the point here. The point is, how can we utilize technology to think differently about the typologies of products or buildings that were created, to sort of offer new ways of thinking about what is a wall, what is a space, what is a membrane, how can we contain, and when you think about that, you can sort of juxtapose Pompidou, which was the sort of the machine in the garden, with I think I want to say our approach, which is the garden and the machine. How to think about using or developing technologies that can allow us to create this kind of synergy and harmony with the natural world in speaking its language.
Well, I mean, I also, this approach also becomes visible in this comparison that you mentioned the silkworm as a natural 3D printer, right? So you can also go beyond the machine and just see natural processes as something that deliver the same when you learn their code, when you understand how to redesign rules of a game, of behavior, but still based on an ethical background, no? Where you're aware that you have to do with living beings. And I also like the metaphor that you used, I think, in your TED talk, where you were speaking about the tree and the fruit that become one, right? That you think about creating objects where you minimize connections, but you reach a monolithic structure which is easier to produce. And I think that has been a very old dream of modern design. I mean, also in the 20th century, there have been designers who thought about, you know, the single shaped objects. Think about Werner Panton's chair, which is made of one piece of plastic. In this idea of minimizing production steps and minimizing the energy you need for producing something by conceiving the object as a whole, I think has been an old vision in design. And I think you're really getting very, very close to that ideal with new technologies.
Yeah.
But when we look, I'm interested in the inspirations that brought you there, because you know, over the past, let's say, 100 years, there have been designers, architects who have been thinking about learning from nature. You showed images of Buckminster Fuller that you compared to your Silk Pavilion. I have to think about Frei Otto, the German architect.
Of course.
And when we spoke a few days ago, you were mentioning Zaha Hadid, who has a building on our museum campus. Are there certain personalities in design history where you would say these people have given you a lot of inspiration and a new direction in your work?
I think for me, it has definitely been Buckminster Fuller, for sure. Since I was, you know, a young student, I've always found inspiration in Bucky Fuller, especially in his synergism and in his not having fear of making science and having respect for science, and also the ability to approach design as an act of science, as an act of not only the creation of space and culture, but the creation of knowledge that then obviously transforms how we think about spaces and places. So for me, Bucky Fuller definitely, and then in many ways Norman as well, Norman Foster, and how he took this legacy, and very different obviously than my own and my team's, but in thinking about how every level of the building, in this case perhaps more the building as a machine, less as a garden, but every element of the building is designed with the same kind of rigor. The materiality of the building, the furniture in the building, the spaces, and there's also this kind of sense that sustainability is not a problem; it's an opportunity. I think in both of their work, both Bucky and Norman's work. So they have been definitely. I mean, there are other heroes. I always, you know, I look up to Liz. I find her so stimulating intellectually. I find her argumentation and sort of using, or the ability to kind of question certain cultural norms through architecture, through her work and her team's work. I find so exciting. And then there's of course Zaha and her incredible drawings and paintings, and whether it be art or technology or cinematography, those kind of channels of expressions I find are so very important to the practice of architecture, because we need to sort of leave to come back.
When you started your career as an architect, you started to study in Israel, then in London and Boston, late 1990s, early 2000s, that was also the time of parametric architecture, right? So where
That's
the
true.
influence of computational design became really visible both in the process of designing buildings, but also in the shape. They had, Zaha was an early example, but I think she also came from the background of constructivism, and not only from computational design, but really from understanding composition and so on. But was this tendency of parametric architecture something in your early career that brought you towards wanting to become an architect? I think your parents also are architects, right?
Yeah, that's right. So yeah, so both my parents are architects, and you know, I had the great privilege of you know, of studying in a science school, in medical school, and then studying in an architectural school, the Technion, the Architectural Association in London, and then studying in an engineering school. So I've had the privilege to sort of explore design through these different lenses: science, engineering, and architecture and design. I always wanted to be a doctor. I applied and was accepted to medical school and stayed there for almost 3 years when I realized that it wasn't meant to be. And I dropped out and joined architecture, and that was it was a love affair to enter design. I think that you talked about parametric design. When I came to the AA, it was all about parametricity. Of course, everybody was doing parametric design, and I think that really inspired and informed the path forward, because what was lacking, I thought, was a kind of sensitivity towards the material practice. There was a lot of focus on form and on shape first, sort of shape first, material later, and that sort of inspired in me questions about that kind of dimensional mismatch between the physical environment and the digital environment and the biological environment. And so I think that's sort of what triggered me towards the PhD, which then focused on material-based design computation.
And that was, I think, in 2005, and in 2007 already, there were works of yours in the MoMA exhibition, right? So it went very fast, I think. And what you combined then was really this interest in parametricity, but as you mentioned, also probably inspirations from Bucky Fuller, and this deeper interest in understanding natural structures. And I think I really see these tendencies coming together in your work. When was the moment where you really started to create those first biology-inspired structures? Was it at MIT after having started the PhD program? Do you remember that?
Yeah, it was actually at the Architectural Association in 2000, the early 2000s. I think it was 2002 when my first thesis there was dedicated to helical structures in nature, actually. And it was called Performative Morphologies. And the idea was that you would or could use an interface, a digital interface, to form generate based on environmental and material conditions. So on the one hand, you would have the environment, on the other hand, you would have material constraints, and you would feed those into the computer as sort of separate objective functions, and then you would get, quote unquote, the form for free. And so I toyed with some of these ideas for the duration of my diploma at the Architectural Association. And that thesis, Performative Morphologies, later was the foundation for the PhD. Okay.
And then you had an incredible 15 years. In the last 15 years, you must have worked like crazy on all those different projects. It's really impressive what kind of output you produced. And I imagine that's also partly teamwork. You mentioned that you work with biologists, with material engineers. How do we have to imagine that collaboration? How does it work? I mean, if you 3D print with pectin and with chitin, Does a
Yeah.
biologist come to the table and say, well, here I have some chitin, or I had some shrimps, so I have some leftovers. Couldn't we 3D print with that? How does it work practically?
Yeah, it sounds easy, right? But it's the opposite of easy, and it's true. It's been 15, 20 years of nonstop work, and it looks wonderful and vivacious and sort of intellectually rich, but that obviously took a very, very long time in writing all these papers and publishing. I always tell my team members, you know, we want to show up at, you know, on the cover of Nature or Science, but we also want to be in Paula's show at the MoMA, and that has pushed us, our team, I think, forward on both fronts: the art, the science, the engineering, all through the lens of design, of course. And the team is everything. The team is the family that enables that kind of life. And that means you work together, you live together in a way, professionally, so not literally, but you really share so much with each other. And I think, you know, we've thought about the group as a kind of Noah's Ark, more or less two of each. And even within those two, when you think about biology, you have a biological engineer and a biological scientist. Even between them, there's a lot of productive friction. One is looking at biology as a science, the other is looking at it as a set of available technologies. And that's a very, very interesting way of exploring a topic. The way I've set up the group is sort of based on the framework of the Krebs cycle of creativity, the idea that the input for one domain becomes the output for another. So if you think about science converts information into knowledge, and then from science to engineering converts knowledge into utility. Design takes that utility and creates new creations that sort of challenge our perception of space. And then an artist looks at reality and changes the actual perception of reality, and then the cycle continues. So some of our team members are focused on one domain. They're either scientists or they're engineers. Other team members are more feel very comfortable traversing these domains, but working together. I think when we start with a material system, we explore it for the potential scientific opportunities, for the potential engineering. How can we shape that materials in new ways, and what might the impact of such processes be, etc. It's almost like conducting an orchestra.
I imagine, yes, and an orchestra that plays tunes which are really which have never been played, no? So it's really
it's hard work. It's hard. No one ever asks about it, but it is hard work.
I totally imagine. I totally understand. If you look in the future, are there certain projects or studies that would be like dream projects? You know, where you would really a scale in which you would love to work, or a certain, maybe even a commission that you would love to get, where you would test new grounds or work with existing processes in a different context. Is there something you would dream of?
It's maybe less of a dream project and more of a dream practice. And that dream practice is a practice where nature is the single client. And what does a practice like this look like? How do you fundraise for a practice like that? And what does a client look like? So this is the question that you asked about, a dream product. Maybe this has been sort of my dream question that will hopefully lead to the dream commissions. But what does it mean to design with nature as your client? What does it mean to design where you're considering all species as equals? So these are questions that I've been thinking about almost, I want to say, rigorously over the past months in setting up the new practice. And we are actually in the process of launching a new company. And you can see some of our work in oxman.com, and obviously the work of Mediated Matter at MoMA. we're in the process of launching a new practice, and I'm excited to reconnect in the official, the moment of the launch. But yeah, what are those kind of products? Should we design products for a nature that exists without humans? I don't know. These are questions I've been thinking about, watching the news and sort of following very, very closely the trajectory of climate change.
Yeah. Speaking about the last month, you also were in that situation in New York in the lockdown, and you were mentioning that in your career, you had a deeper look into biology. You wanted to become a doctor. What is your perspective on what has happened in the last months? Did that even change your attitude towards design further? Has that opened new worlds that you're thinking about? To me, it seems nearly, what you're describing and your work of the past 15 years seems to anticipate a lot of the sensibility that people have now developed during the lockdown. But I'm sure also for you, this has brought a lot of new ideas. Can you tell us about that?
Yeah, such a beautiful question. I think it anticipated with luxury, right? I had the luxury of being in an academic institution where I still am, and exploring open-ended questions. But then when you sort of contextualize that in a company or an organization, it becomes hard. Okay, what are the actual acts of translation that can have an impact, not in creating 1 or 2 or even 20 beautiful buildings, but in completely redefining the design industry, if I may call it such, from the bottom up entirely for the world at large. And how can we make an impact that is beyond, beyond designing, a beautiful chair? And don't get me wrong, I still get turned on by a beautiful chair, and I love, a beautiful.
Don't have the excuse.
Yeah.
You don't have the excuse. I'm fine.
but there is sort of this bigger, more perhaps urgent force in me that actually showed up when I became a mother, and sort of was emphasized under quarantine, where, hold on, there's a limit to time. This is it, right? If we pass the 600 ppm if we surpass that by 2025, actually all hell breaks loose, and the fires and the pandemics are just first indications of what lies around the corner. To me, it's beautiful that you say that the work anticipated that, and I appreciate that. I think I was operating more from the place of a group of artists. I think now we were looking to move people, to even trigger an emotional response in people. Wake up, look at what is possible. But now there's this responsibility to think even bigger on and how to make an impact. Hence, thinking about the launching of this new company. Yeah, it's a different kind of existence. It's sort of living in dog years as opposed to women years. It's sort of a call to arms and a wake up call to it's very nice to be able to sit in your drawing board and by your drawing board and design a beautiful object in the computer. But design has to move beyond the object to the system. Designers cannot no longer commit their talent to the design of a finite product or a finite building. It has to be more, if we're to survive on this planet, and even if this planet is to survive with us, which it will, of course. But these are some questions that I've been asking myself over the past months, and of course the relationship, and I may be criticized for that, but I do believe in the intricate relationship between how we've treated the environment and the appearance of the pandemics. And I think there's absolutely an intimate link between climate change and the pandemics, and that is expressed in many levels, many organisms, many species, and we can talk about it in another time. But there's definitely this kind of connection between environmental forces and and viral appearances and forces that shape our life and world.
Well, you were mentioning it before that you can either design or work against nature, and that's what we see in climate change as a result. And I think this was also at the beginning of pandemics, that we do not respect certain limits of where we live, how we live, what we eat, and then these processes in nature start to get out of control and start to turn against us. And what you're proposing is designing with nature, understanding its processes, and rather trying to work with it, which I think is a model opposed to what we see now in its consequences. That was also already one of the questions that our audience sent. Actually, someone asked us, how did COVID affect your work? So you already answered that. I just looked at the questions that some people said, because we said we were taking some questions. So another one I like, because it's nicely old-fashioned. It's what book would you recommend to any student or designer? You know, it's not a blog, it's not a website, it's a book. And you, as a very progressive person, I like to ask you that question.
So on Growth and Form and War and Peace, maybe it would be my picks. So I grew up with Darcy Thompson. I often revisit on Growth and Form, and there's a wealth of knowledge there. My thesis sort of revisited chapter 5 and created a PhD out of that theory of transformations in a material context. But there's so much more, so many more theses to be written. So that would be one. And then War and Peace, you know, understanding human nature, accepting it, working with it, loving it, the hardship, the challenges, and understanding that design is not a material practice per se. It is, you know, it is a practice that involves humans, it involves other species, it involves materials, it involves social forces and environmental forces. It's the practice of living, you know, and leading with the heart, and it's and I think we're now, as designers, we're at a point where we cannot afford not to look at the bigger picture. You know, there's this inner urge to change, to make an impact for the good. And now at such a challenging time for the planet.
These are such wonderful closing remarks, Neri.
Thank you so much, Matteo. Thank you, everyone. And I apologize that I was a minute late. And thank you, everyone, for tuning in.
Thank you, Neri, for having been with us.